to displacement. So this is the displaced figure. I'll just go with the ultimate. As you can see, we have two load cases. We have the ultimate, the bottom one, then we have the service load. And this one is also giving you the maximum deflection as 0.007. This one is in meters. When you convert this one to meters, then utapata ni kitu kama, someone to convert this one? Innocent Tesha. What is this one to meters? 0.0079. To meters, what is this? To millimeters, I mean.
Millimeters.
Yes.
It is 7.9 millimeters.
Thank you. Now, 7.9 millimeters, this is for serviceability limit state. But now we have done a mistake. Never check the ultimate, the deflection using ultimate. As you can see here, this is a mistake. Don't check your limit set using this. Please be checking using serviceability. I think I discussed this one with some of you. So right now, as you can see, it acquires 5.64. Now, this 5.64, you have to come to this structure. Now, which is what was our longest beam? The longest beam was 4.6. I think it was this one. So when you take 4600, according to table 3.9, you take that 4600, then you divide it by 250. What do you get? 4600 divided by 250. What is the answer? We are not so fast. Wesley alienda wapi? Wesley, I know you are just doing your own things.
No, I'm in a meeting. 18.4.
18.4. When you are in the meeting, Bwana talk. I know you. You are telling us these things. Now 18.4. So that is good. Now another point is this. So 18.4, that is the limit. That is the code. Acha niwafungulie tusikuwa tunaongea theory mingi hapa. By the way, tumeongea theory sana, but I hope you are following, because I'm only telling you what exists on this earth. This is the code tempo 3.9 pale juu. Listen to this. Natumianga software ingine mbaya hapa. This one's 3.5. This one's 3.9 is here. Now listen to this. 3.9, this one. So please listen to this. What's this? Good. Wanasema the basic span, remember, tulitafuta basic span. Basic span is the longest short span according to slab design, the slab design. That is the basic span. According to beams, basic span is the longest beam span. The longest span in a beam, that is the basic span. So when you take basic span divided by the effective depth ratio for beams are given in this table. These are based on the limiting the total span, the limiting. Wakisema the term limiting, this means that is the limit that you cannot go beyond. I think that statement is so clear. So that is the end point. Please don't go beyond that. Hooke's law. Hooke's law tunasoma ya kwamba this spring will try to resist this load up to a certain limit. But when this limit is reached and or exceeded, when the limit is exceeded, now the spring fails and it will not go back. It will now undergo what you call permanent deformation. If it's a structure, unapata column inamwagika ina crack and fine. So by limiting the total deflection to span divided by 250. Na hiyo 250 imetoka hapa. I hope bado Mungu anafanya kazi safi. So you take span divided by 250, unapata 18.6. That is the maximum figure that when calculated, you should not go beyond. And when we come to this one, according to serviceability limit state, the calculated maximum deflection or displacement is 5.6. So you will realize 5.6 is way below the limit. Now, Innocent Tesha, has our structure passed the design ama imefaili? Is Innocent in the meeting? Because I don't want to be here as I check. Innocent, has our structure passed the design ama imefaili? Okay, Ephraim.
Yes.
Okay, yes. Hello? Who was that?
Gala?
Yes, Ephraim.
Yes?
Now, our maximum calculated deflection is 5.6 and the limiting value is 18.4. Has our structure failed or has passed the design?
It has passed the design because it's still within the limits of, from the one that we calculated of 18.4. So
Okay,
if
thank
it
you.
did gone
So
beyond, it means it is
it
fine.
will fail. Good. So after performing the design analysis, so we will get the analytical model means the analyzed model. The model now that we have now converted the loads into moments, shear force, axial force, and everything. So how do we see them? First of all, we will try to animate this building, what we did in ETABS, and this is what you'll get. You see, so this is according to serviceability limit state. Another thing, don't animate your building based on service. Like these things, you guys, we need to know them. First of all, don't perform deflection based on what? Based on the ultimate limit state. I think that point is somewhere here. Should be somewhere here, somewhere here, somewhere. I don't know. It was in Klaus somewhere. I don't know. So, but I think some of you knows this. So for the animation, please don't do it using the ultimate. Using the substability, we will use the ultimate. For ETABS, if by any chance there is some connectivity issue, then you are building all of it will go down, and you'll see like you'll just see it as if you are watching a video. Your building will just go down. So this is the animation, the animated one. Now after this, we'll now go to forces to see the reactions and so on. So as you can see, the values that we just got in ETABS, they are just the same, 300, 400. The biggest value was 800 and something. Let's check this one. The biggest value was somewhere the middle column. As you can see, there's one column here giving us 839. I think this one is okay. So this one is the axial loads. This one. You can also check the moments for beams, M33, and these moments can also be checked. You can just uncheck all this, where you can also uncheck the floors, the slabs like this. Now let's turn on this grid like this one, this grid. So we can just concentrate on focus on this beam alone. As you can see, if we did with ETABS, let me just switch to ETABS because we still have it. Okay, we can display forces here. Then this one, let us just concentrate on this M33 for beams. As you can see, the moments, I don't know which one is this. Let me go back. As you can see, these moments, it is below 30. Like the moments are at two. Let me check. I think this one is, oh, as you can see, this one is also way below. It's even below 15. So these moments actually, when you go to prota, 20, 19, 19, like that, 5, 5, 5, something like that. This one is 36 or 7. So for these moments, actually 3 to 12 will just work. So this is how you explore the analysis and confirm your results. We can also go to another view, 20s, as you can see. So after doing all this, okay, you can also uncheck the beams. You can check the shear walls, uncheck the columns. But for the columns, we really need to see them. I don't want to see the axis. You don't have the shear walls. You can remove the beams. So you can remove the beams and concentrate with the columns alone just to get the forces. These are the moments. You can also just concentrate on columns and get this. So, okay, I think now, what's this now? My laptop is now hanging. I think I'll go here and come. Hey, there's a problem. Let me close the analytical model. Nice. If you get what you want. And what do we want? We want to see if this building is, first of all, passing the design. How do we do that? You go to review, then status. This one, review, then design status. As you can see, is any member failing? Ephraim, I think you are still there. We've been communicating with you. And some other colleagues in the meeting. Ephraim is from Zimbabwe, an engineer, civil structural engineer, now in the field. Yeah, Ephraim, please. Are we together?
Yes.
Now, as you
Yes,
can
we are
see,
still together.
yes. So as you can see, immediately after performing the because for your model, most of the model that you've been sending them to me, most of them have been failing, especially the bottom columns. You'll find out that bottom columns are failing. So make sure next time you perform the analysis well, then you also assign the loads well. Consider all the floors that get the required loads. So this is okay. After this, detailing. Now let's go to detailing. We'll start with the prota, then we'll finish with ETABS, then we'll call it a meeting, and we'll also call it a day. So how do you do this? You'll come here to, first of all, you can come here to design, but is there any need? Let's just go direct to detailing because all the members have passed. I just come here. Before this, sorry, we have to design the foundation. Sorry. Now to design the foundation, Prota is very intelligent. You just have to right click on this column, or let's pick all columns. I'll just select all the columns like this. Then after that, I'll hold shift, not shift, control. Hey, what's wrong with this? Is it shift or control? Okay, control. So you hold control, then you right click, then you tell it insert pad footing. Now let's go. So it is performing the calculations at the same time it is designing. So I don't know what's happening. Let's give it some time. I don't know. Something is happening. Now I'll just close. Let's place one first. Let's insert one and see. Okay. It's misbehaving. Now, after finishing any step, you have to save your model. Otherwise, so I don't know what's happening here. Okay, let me save the model first before I control S. Nice. So I'll come here, right click, then insert pad. So it will give me the calculations. As you can see now, my pad is failing. And now it is failing because of the reinforcements. For the, wait, it's now giving us 6. The diameter of reinforcement is 0. Does it mean that we never selected? Like, wait, let's go back to analysis here. Building analysis here at this point. Then foundation, rebus. We have T12. What's the problem? Let's add this one and see. But now you know the problem with this, we have to analyze again. But the good thing is that I have explained almost everything to you. We are only trying to come up with an economized thing, design and deliver the results. So for such a building, all the members that we just precised using the Excel have passed, and we can easily perform the detailing and submit the documents to the client or to our seniors. Now this is okay. Okay, let me close this. Of course, it will open the analytical model, but so this is a very big problem with the prota structure. If it comes to this one, I don't know what is. There is some people who I think at the moment have you have to, at least after installing the software, you have to restart your laptop for all the settings to be active. Otherwise, you'll encounter these problems. So I don't know what to do. The only thing to do is to close and see if we have it. Otherwise, we have a problem. End task. Okay. I'll hi. Prota. Please sorry for this. You know, when I restart my laptop, this means I'll have to get out of the meeting again. And it's really late. Let me try and see if we don't have the model. The good thing is that you've understood what the procedure is, and to make sure that the model passes the design. And another thing, okay, we have it here. As I said, it's a good thing. And Wesley can testify this. There's an engineer yesterday who just told us in the office that whatever you do, as much as you are using any software, you have to each and every time either to save us or to save your model. I think I think I can now confirm that, because now, okay, let's try and put the column. Okay, before this we have to perform the analysis, and this analysis, I don't know why are we not having the okay, let me see these settings. Okay, I'll come to these settings. We have this icon for the settings. Then I'll come to this foundation. I'll start with the general information here. The minimum steel bar selection, the minimum is T12, not T16. Oh, now let me tell you. For our case, we specified T12 only, if you can remember. But from the general settings here, from these settings, the T16 was here. So the software is trying to search for your for the bus that we actually gave, but it does not see T12. It does not see T12. T16, I mean, it does not see T16. That's why it gave some errors. So if we give this one, then this one will work. So let's just right click. This one will work. There's no need even. Okay, let's go one by one and see. Right click, then insert pad. Then you can also use prota to learn. If you want to learn how to play, as you can see, we have 1100 by 1100 column, the base, that is okay, with a depth of 400. So what I'll do, let me just select all this. And it's now using T12 because that is what we, okay. I don't know what's wrong today. Right click, insert pad. Now, it will actually design all the pads and insert all the pad footings. Now, as you can see, all the pad footings passed the design because everything is okay. And as you can see, we are just using 2T16. We'll discuss this one later. I'll tell you why it's doing this. If you want to make sure that the T12 is the one in use, I'll tell you how to do that. Now, so as you can see, everything, including the footings, are now showing the right color. Everything is now showing the right color. And if you want to know the size, this one is 1400. This Josephat is in the room, and Josephat, and there is this engineer, my good friend, engineer Prosper. Yes, Prosper is also in the room. I think you can confirm that these footings are very perfect according to you, according to your experience in the field.
Yeah, it's actually there. Okay.
Yes. So you can now there's a problem here. If two or more columns overlap, what are we supposed to do? You now design a combined footing. And when you go to this Excel, you now have to design combined footing here. If pad footing fails, now you go to combined footing. So you design. So how do we do that? I'll delete this. I'll delete this that are now overlapping. Then select these two columns like this. Then right click, then insert combined pad footing. You can also insert pile cap. Pile cap, I think you can learn prota using that. You can learn how to design piles, especially for bridge and some other serious structures. So pile, as you can see, this one is 1100 by 1900. You can use 1000 and see. So 1000 is failing. We can go for 1000 and 1900. It's also failing. If you design, it will go back to 11 by 18. It always so it is giving us 12 by 16, which is okay. We'll go with that. Then we will select this. Sorry, we'll select what's wrong. Select, then click, then insert pad. I think this one is okay. Let's go with that. Don't need to change, but we can just keep this and this one to be okay, to be similar, and all other columns are okay. Now, what is now the point here? So you can also view the 3D, how this column, this footing is behaving. You right click, you go to properties, then you can view them in 3D here under 3D. This one can help you to see to visualize. As you can see now, this is how the building is behaving. Four columns, 40, 12, and some other, and the reinforcements. So this one is very important, and the calculations are here. These calculations are very, very important. You can generate the report, of course, here, which I don't want to do that because of time. Now, we'll go here to, we are done. Everything is now okay. Everything is now okay because in 3D, this is what we have, and the building is smart. So we will go here to drawing and reports. So Ephraim, wherever you are, please pay attention because now you have to pick up from this. So under drawings and reports, we will launch prota details. Remember, while installing prota, it will install 3 softwares. You have prota details, prota structure, and prota steel. This one is for steel detailing. This one is for concrete detailing. Now, prota details, launch it. Do you want to save? Of course, I'll allow it to save. Then it will launch prota. Just a minute. Okay, now, as you can see now, the name of the model or the name of the project, we named it project. If you go to prota here, the name of the project is okay. Then, now, listen to this. We have different ways of doing this thing. But now, because of time and seems like I'm also exhausted, I just want to go to a very general way, but some other ways I'll be sharing some videos. I'll be doing some like 20 minute video and send them to our Telegram. Then you can be learning through that. So what can we do after now opening the prota details? This is now something good. Here you can start by creating a new drawing, or you can just auto-generate details. So for this one, I'm just going to use auto-generate details because of time, but it's good to customize. Like you put the columns here, you put the beams here, you put the foundations here. But for this one, it's just going to do it randomly. So I just click this one. As you can see, all stories are coming. Everything is coming. Those, I'll just click. Okay, this one. I think, wait. Now, wait a bit before we continue. Let me take you back to prota here. Before I do the detailing, let me show you something under design of beams here. Now, as you can see, all the beams pass the design, but I want us to select one beam like this. You just click on that beam, then you right click. So this is the beam. This is the start and this is the end. Grid A, B, C, D. This is the beam, of course. Then for this beam, as we said in ETABS, and there is nothing here that is so difficult. It is only requesting for 2T12 fall through, and this is what we said. So how do we see, how can we visualize the detailing of this thing? We can just come here to detailed drawing, click on it. So this is what you will get. So this is how prota will detail our beam. curtailment is somewhere here. Now, as you can see at this point, don't ever do your curtailment or lapping. Let me say lapping. Don't ever do lapping like this. This type of lapping is so bad. This one, we always lap at the column. Even for the slabs, we always lap at the where the beams are now. We search for where the beams are crossing the slab. Then we lap at that point. So this one is wrong. So what are you supposed to do? We have to do some settings. And what are these settings? So we'll come here. Let me close prota first. This one, I'll just close it. We'll come to this setting. This one. Then we'll start by here by the we'll start by opening the details for the beam. The first thing for this one, we'll come here to design. Design has already been done. Now, we have that design that is always done at column face, but by manual or by what we know, we always design our beam based on at a distance d from the column face. So we could have picked this, but because our design has already been done, let's just continue. But next time, please make sure you do these settings, then design using this one at the face, at the column face, then parameters. So for the parameters, I think this one is okay. The minimum is this one. Everything is here, it's okay. What I want is now the detailing. So under steel bar selection, we have a rebar spacing optimization. Then we have rebar diameter optimization. How are we going to select the spacing of the bars or the diameter? Of course, here we have to use the diameter, but because we already used the spacing, let's just go with spacing. We'll discuss this one later. You have the design. Now this curtailment is what I said. You cannot curtail your beam like this. This is so bad. So you have some options here. You have that one, the bend up, bend down. So we will not go with that. You have type 1. This one is the poorest. Type 2. Type 2, this one is now the better one. But now these beams have to, like for example, this bar, this bottom red bar has to extend to this span. Let's see type 3. This one is the poorest. Okay. Now we'll just go with the type 2 because now, but I don't like this one at all. Let's go. I think type 2 is okay. Let's go with type 2. But next time, please, you have to learn how to customize this because, where? Now, under detailing, we have beams. So for this one, for the beams, you have the beam label. This beam label, we'll just keep it. Use beam insertion axis as beam label. We will not use this one. This one is the beam axis and everything. We will just use the beam label as it is in the plan. Then we have to print beam labels below the detail. This one is okay. So if we remove this one, the label will come at the top, which is not good. You can underline or remove this underline. Shift outer layer bars to enhance display. Okay, we can just leave it. Then display beam reference labels. Leave alone with this. This one is like to give the reference that this beam has been obtained from story 3, something like that. We don't need that. Then for the sections, we don't need all these sections, by the way. We only need like one section per. So we have the span section only. This one, we don't need all these sections unless otherwise you can introduce some. This one, beam sections for different beams. We need sections for each beam like this. Then we have beam section labels. We can use 1, 2, 3, but you can just select what you like. I like A, B, C, D. Then you have to restart selection labels in every axis. This one is okay up to that point. Then you have steel bars and links. Now, pay attention to this point because now at this point, you have to replot the bars below, annotate steel bars in beams. If I remove this, now you'll now realize we don't have the beams, but now we will keep them. So this one, annotate bars in beam sections. This one is okay. This one, as you can see, if I remove this, you'll just see if I keep it, you'll see the labels. Like this one is AA. So this one AA, you'll now get the information outside this beam, but we don't want this. What we of this is this. Then you have to print bar, steel bar, layer information. So as you can see, this one is 2 to 16. But if I introduce this one, we will have that one now, the bar mark. Bar mark are show the column dimensions if you want something, but I don't want. Let me just draw. I'll draw them here. So it will take some minutes and include everything, as you can see. So foundations, all of them drawn perfectly. It will take time. Now let me launch AutoCAD because I want to show you the last thing. Now, as you can see right now, all the foundation details are here. This is the foundation layout. As you can see, this is the foundation layout. This one is the foundation layout. So you can print this one just to show us this one as the foundation layout. And this one is the general layout, the one that we created in AutoCAD. Then this one is also now the general layout will be per floor. That's why I told you it is not a good practice. You just have to select like one floor, then design it. But it's also good. You can present this one. You can send this one to AutoCAD and do whatever you wish. So this one is the column what? Column layout. This one, column layout per, I think, which floor is this? This one is level 3, the bottom level, the story 1. As you can see, we need 4012 for this column, 4012 also, 4012 with the bar mark 3 is very important, as Joseph said. 4012. Then this one 40, almost all of them 4012, all of them, because as you saw, we don't have small, the loads are so small. So for per floor, as you can see, per floor, first floor, second, third, fourth, fifth. This is now the good thing with prota. And to any person that you give this thing, it's not a must that you come up with this because as you can see, prota in detailing the column, the longitudinal section, it is so poor. That's why now you need ETABS or you need Tekla structural designer. I'll make a video and send the video to link to our channel, alafu we will see that. So all this, as you can see now, the beams, these are the beams. Like for this one, we need 16 by Mark 2 at 300. For the students, I know we have. Okay, I can just take it here to online. Then okay, then export. So it's going to export the DXF file. Then in ETABS, in AutoCAD, you can now open it. It's exporting. As you can see, it's export. Okay. What happened? Okay, AutoCAD. Then open. Now, where is this thing now? Where? Online session. This one. Do we really have something like? Okay. It's somewhere inside the files. Online drawing one. This one. Continue opening the DWD file. So right now, as you can see, this is now our drawing. But these drawings, unless otherwise, they are not to standard. They are not to standard. Like you have to have your document to make sure that your documents meet the standards required. So we have this tool. Though I'm making my own tool. Okay, I'm making another tool. I'm making another tool, which I will launch it very soon. But for now, we will use what we have. AutoCAD 2024 Stonebridge. Yes, we have Stonebridge template here. So what we can do, we have some drawings inside this template, of course, but what I'm going to do, I'm going to copy these ones. Though it's a very heavy thing, I'll Control C. Then I'll come to the Stonebridge template and paste them here. Control V. So it will take time. I'll just put them, let's say here. Okay, so okay. Now it's done. So as you can see some changes. Even the color of the color, as you can see initially when we come to this model, you cannot even tell if you cannot tell some of the things, but as you can see inside this template, so everything is now somehow visible. So it's just upon you to edit some things. For the foundation, you can just put some beams here and then come up with your strip footing. Then that is all. And as you can see, this one is also okay. It's just a matter of editing some things, but all the drawings are now okay. As you can see, this one, if you try to print this one, if you come here, I don't know if it will print. This one is Stonebridge template. So inside this Stonebridge template, you can just double click. Then these are our drawings. Okay, you just have to do some editing. I'll send the video for editing. That one I can send it even now. I'm just going to send the link. Please follow it. Then using this Stonebridge template, you will get some very nice output results without struggling. I'll use the general documentation. Then okay, I think this one is just okay. Yeah. Now, as you can see now, this one is somehow okay, but some editings have to be done using this Stonebridge template. You just have to pick some layers and put them to some layers. Like this, the layer for this naming of the beams. You have to turn this layer to layer 0. Like you have to change the line the thickness to 0. Now, that marks the end of our today's session. Please make sure you do the column sizing. For all the people that I have worked with, first of all, they always complain. Why is it that you are doing okay, I wanted you to check the beams, but as you can see, the beams are totally perfect. It's just for you to do some editings. Like for this one, you can just select this. You can unblock this beam, then curtail it well or lap it well at this point, but we will discuss that one later. So make sure you perform the precising, especially the columns, because if you don't do that, unnecessary moments will be created for the columns and the problem will now be for you, because you'll now have to figure out how to edit the columns which will have failed. It's actually tiresome, especially when using AutoCAD. ETABS, it's very easy. So I'm going to send all the files that we have used today, including the video. I think it's now too long. Let me stop it. It's 4 hours 37 minutes. I'm not going to edit anything in this video. I'm just going to send it as it is, because editing will take a lot of time, and we still have some errands to run. So what I'm going to send, let me start by sending this, the Stonebridge template. Just name it template. Now, you can unmute yourself, ask any question as I send the required documents, because I'm going to give out some assignment, and I will request for the answers.
On my side, I appreciate there is no question as at now.
Okay, Wesley? Ephraim? Is Ephraim with us?
Yes.
Yes.
I'm
Do you have
here.
do you have any question? Because now it's like we've come to the end of our session.
No questions. I think if I get the video, then I'll be able to work on it, especially on the ETABS. It was the first time that I was
Okay, but if
doing
you,
it.
and as I said, if you get any problem with any software, just let me know. We can always discuss and help each other. For the ETABS, I'm going to send the video, and you will learn a lot. Which other files? I think this is okay. Yeah. We still have some other engineers in the room. We engineer Prosper. Prosper? Kindly unmute yourself. Yes, Innocent. I think Innocent is out of the meeting. Tesha? Yes. Yes. Okay. Yes. Now, I think your question is totally good and valid. For the columns, what we always do, first of all, if we are doing low-rise buildings, we always use a uniform column from the base up to the end of the building, the height of that building. But if, for example, you are doing a high-rise building, let's say 20 plus floors, so you'll find out you divide this building into two sections. The first section, that is from ground floor to a 10th floor, let's say, for example, to a 10th floor, you can use a different column size, because now at this stage the loads have accumulated. There are so many, and because we also want to take care of the economy, to make sure that our client is not suffering, so we have to do it. We have to now change the size of the column from 11th floor up to the last floor. So, but for these small structures like the one that we just did, we just work with a uniform building, a uniform column, but now reinforcements are the ones going to change. I'll give you an example. Let me show you something here. I don't know. Okay, it's here. This is good. Now I'll give you this example. For example, as you can see, this column, this is a column of 200 by 300. This column, the loads. These are the loads. These are the reduced load. Let me not reduce these loads. Let me just have the all loads. Now, for this column, as you can see, the top column is having 124 kilonewtons, 300, 500, 7, and the bottom column is having this. So But now when we convert this load into the area of reinforcements required for these columns, you'll find out that the top column is not even requiring any reinforcement, like negative. It's giving you a negative figure. So this means the column itself is in position to take care of all the forces. So this means we don't need reinforcement for the first column, the second one, the third one. But from the fourth column is when we need some reinforcements, fourth and the sixth. So the only thing that will be changing is actually the number and the size of reinforcements. Like for this one, we can be using T12. Let me try T12. T12 will work. Even at this point, T12 will work. This one will also work. Sorry. T12 will work. Let's try T12 here. T12 will also work because it's giving us an area for 452. But the bottom column, T16 is failing. So this means we can now go for T20 for this column for it to work. So the thing that will be changing actually.
Excuse me, engineer. I'm sorry for interrupting.
Yes.
It's Noel.
Yes. Noel.
Yeah. Thanks for everything. I feel like my phone is running off just as soon.
Okay.
Yeah, and I don't have the access here to recharge my mobile. So
Yes.
I appreciate everything, engineer. And my request is just maybe you sent me the link to join the Telegram group, but unfortunately the link it seems like it's not working. I tried to click, but yeah, it's not allowing. So please, if possible, you can join me there so that I can get the rest of the document that you shared with our fellow engineers.
I'm going to do that one immediately after the session.
Thank you so much, engineer.
Okay, welcome.
Thank you.
Yes. Now, I think that is okay. Do you have another question? Josephat, I can see Innocent. Innocent, do you have any question? Tesha? Okay, that's nice. We started our session some 5 hours ago or so, and we call it a day. I'll share the video. I'll share the link to the video, and you can actually follow it. And for anything, just let me know. Is that okay?
It's okay, Engineer Kisasati. Thank you.
Sawa. I wish you guys a fantastic evening. Let's be in touch. In case of anything, I'm always available in all ways. In email, you can get me. Telegram, I'm there. Or WhatsApp, I'm there. Phone call, I'm also there. I'm always available. So just let's discuss and help each other in the best way that we can. Otherwise, have a good evening. I'm going to share all the files and you'll get them to our Telegram. And Ephraim, please, you told me to you have to change the number and rejoin to the Telegram group because I'm going to share the documents there.
Yeah, I'm sorry, I'm Prosper.
Yes, Prosper.
Yes, I was not being able to talk because of the mic problem.
Yes.
I congratulate you. It was a very good presentation. I appreciate it. I think I'm the oldest here. So things are really moving faster. I'm 20 years experienced engineer. But
thank you, engineer. And we appreciate for you attending this session. Thank you.
It's about these Excel sheets. I can see
yes.
you do only for 5 floors. Do you have how many floors can you do using the spreadsheets? The loads for how many floors?
Oh, this spreadsheet that's up to 20 floors.
20 floors.
As you can
okay.
see, yes, it will